just come back here. So this is the formula for the Taylor polynomial, and you just need to memorize it. Let's do 2 more examples. So here's another example. Say f of x is cosine of x. And let's do again, let's do degree 5 now. Let's center that at x equals 0 again. So what we need to do is we have to plug into the formula. So we need p of x, so that's going to be f at 0 plus f prime at 0 times x. You don't need the parentheses there. Plus f double prime at 0 times x squared over 2 factorial plus f triple prime at 0, x to the 3 over 3 factorial plus x to the fourth derivative, f to the fourth derivative of f at 0, and last but not least, the fifth derivative of f at 0 times x to the fifth over 5. So to find the polynomial, all we have to do is just plug in. So this is just the formula you have to memorize, and then you just have to figure out what the only things you don't know are what these are. And of course these are determined by, well, the function and the point. I mean, that's what they are, where they come from. So we can just set up some calculations. So we'll do some preliminary calculations. So f of x is cosine of x. So we just need to calculate all the derivatives up to order 5. So the first derivative is minus sine of x, and then the derivative of minus sine is minus cos of x, and the third derivative, that becomes positive sine of x, and the fourth derivative, that becomes cos of x, and last but not least, the fifth derivative becomes minus sine of x again. So now that we've done that, we can then start plugging in with 0. So cosine of 0 is 1. Sine of 0 is 0. So negative of 0 is still 0. Second derivative, I'm just plugging in zeros into here and writing the corresponding output. That gives you negative 1. F triple prime of 0 gives you 0. Fourth derivative at 0 gives you positive 1, and the fifth derivative at 0 is also equal to 0. Okay, so if we put that all together, then we can write out what we get. So just putting everything together, we see that this polynomial looks like, well, it looks like 1, and then plus 0x minus 1 x squared over 2 factorial plus 0 over 3 factorial x cubed plus 1 x to the 4 over 4 factorial minus 0 x to the 5 over 5 factorial. So I just wrote it all out so you can see the parallel, just so it's all aligned up. Just aligning them all up, this. But of course, there are lots of zeros here. So this Taylor polynomial is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. And so there actually is no degree 5 element. So the degree 5 Taylor polynomial is the same as the degree 4. So since it really is degree 4, I'll just call this is the degree 4 Taylor polynomial of cosine of x centered. So I'm using this language now, which I haven't used before, but we sometimes say it's centered at x equals 0. So that this is a Taylor polynomial, so this thing has the property that so p of x, so p prime, and p double prime, and p triple prime, and p agree with cos of x, cos x prime, cos of x double prime, cos x triple prime, cos of x to the fourth derivative at x equals 0. You can just check. So for example, if you plug in p of 0, you can just see what happens. So p of 0 is 1, and then of course that's the same as cos of 0. If you take the first derivative, p prime of x, use the power rule, you get minus x plus x to the 3 over 3 factorial. So if you plug in, that's what you get, sorry, so that's what you get. So if you plug in 0, you get 0 again, and of course that is the same thing as the derivative of cos, which is minus sine. Sine of 0 is 0, so this is the same thing as cos prime at 0. It's bad notation, but that's just how these things work. So these are two examples of Taylor polynomials. The Taylor polynomial for the exponential function looks like this, and the Taylor polynomial for cosine looks like this. So let's do one more example. Let f of x be equal to the square root function, and let's find the degree 3 Taylor polynomial centered at x equals 1. So to do this, we have to calculate. We need to fill in this formula, so we need to know what f of 1 is, plus the derivative of a function at 1 times x minus 1, plus the second derivative at 1 times x minus 1 squared, all divided by 2 factorial, plus the third derivative of the function at 1 times x minus 1 to the third power, divided by 3 factorial. So that's just that's just how we write the Taylor polynomial. And in order to do this, we just have to do a couple of calculations. So, because we have to determine what all of these things are, well, we know what f is, and so we just have to take all these derivatives of f and then plug in when x is equal to 1. So let's just do it. So this is the square root of x. Let's use exponential notation, and to take the derivative, we can just use the power rule. So when we use the power rule, that becomes 1/2 times x to the negative 1/2. Take the second derivative, that negative half comes down, that gives us negative 1 over 4, becomes x to the negative 3/2. When we take the third derivative, the negative 3/2 comes down, that gives us positive 3 over 8, x to the minus 5/2. So these are just the calculations. All of these come from the power rule. Once we have those, we can then plug in explicitly when it's equal to 1. So the square root of 1 is, of course, 1. The second derivative, if we plug in 1, so that's just a half. When you plug in, I misspoke, I said the second derivative, I meant to say the first. The second derivative gives us negative 1/4, and the third derivative, when you plug in 1, we get 3/8. So putting that all together, we see that the Taylor polynomial p of x, so this is going to be a degree 3 polynomial, and it looks like 1 plus 1 times x minus 1, sorry, 1/2 times x minus 1, minus 1/4 x minus 1 times 2 factorial, plus 3/8 times x minus 1 to the third power over 3 factorial. Sorry. So again, that's just using the formula. This is f of 1, that's f prime of 1, this thing here is that thing, and this thing here is that thing. So indeed, this is a polynomial. And so students, when they first see this, they have a habit of expanding everything out. So like, oh, sorry, I keep making mistakes. There should be a square here. I left that off. So sometimes students would like to foil that and expand this out, and you don't want to expand it out, you would just want to leave it exactly like this. So I'll write it one more time without all the nonsense over it. So that's like x minus 1 over 2. This is minus x minus 1 squared over 4 times 2 factorial is, 8. And then this is plus 3 x minus 1 to the 3 power. And sorry, I just got, anyways, and the denominator here is 8 times 3 factorial, that's 8 times 6, which is 48. So anyways, you can see that this is a Taylor polynomial. And so the thing to keep in mind is that these Taylor polynomials are actually approximations to the function. They're approximations that agree at the point x equals 1, and they have the same derivative and the same behavior. But we'll talk more about the interpretation of these later. For the moment, I just want you to get comfortable doing these calculations.